Okay, so let's look at some more examples here of these properties. So first of all, our associative property, first for addition and for multiplication. And then this is the one that says grouping does not matter. So I've got a little picture here of some kids who are grouped. It doesn't matter how we group these kids, it's always the same group. If this guy was the leader, he'd still have these three teammates. If this guy was the leader, he'd still have these three teammates. So the grouping doesn't change the team. All right, so for numbers, it looks like this for addition. If we have 2 plus 1 plus 3, that's going to equal 2 plus the quantity 1 plus 3. And we could figure this out. We could say, okay, 2 plus 1 is 3, 3 plus 3 is 6. Over here, 1 plus 3 is 4, 4 plus 2 is 6. So you can see that either way, we get the same answer. For multiplication, it'll look pretty much the same. 2 times 1 times 3 is the same as 2 times 1 times 3. So here we would do 2 times 1 first, which is 2, and then 2 times 3, which is 6. Over here we would do 1 times 3 first, which is 3, and then 3 times 2, which is 6. So either way we get the same answer. Now we can represent these algebraically as well, and it looks like this. So A plus B plus C is the same as A plus B plus C. So you'll see it written that way a lot. Or A times B times C is the same as A times B times C. So that would be the algebraic way to write that. All right, on the commutative property of addition and multiplication, remember order doesn't matter. So it doesn't matter if this person's in front or this person's in front, we get the same three grouping of kids here. So the commutative property says that order doesn't matter. So in this case, we can say that 2 plus 1 equals the same as 1 plus 2. So 2 plus 1 is 3, 1 plus 2 is 3, the order didn't matter. We could say 2 times 1 is equal to 1 times 2. 2 times 1 is 2, 1 times 2 is 2. They're equal, order doesn't matter. The way that looks algebraically is we could say A plus B is the same as B plus A, or A times B is the same as B times A. And that's what it looks like algebraically. All right, our identity property of addition. Our identity property of addition says that anytime we add 0 to a number, we don't change the number. So we could say that 2 plus 0 is 2, and we know that to be true. Anytime we add 0, we get the original number. And algebraically, that would look like A plus 0 equals A. Identity property of multiplication, pretty much the same, except we're multiplying by 1 instead of adding 0. So 2 times 1 equals 2. Anytime we multiply by 1, we get the original number back. Algebraically, that would look like this. A times 1 equals A. The inverse property of addition says that anytime we add a number to its opposite, we get 0. So if I have 1 plus a negative 1, I earned $1, I spent $1, I get 0. Algebraically, that looks like A plus negative A equals 0. Okay, our distributive property, probably the hardest one here to remember, says that I can take the number outside the parentheses and distribute it to the number inside the parentheses, we'll still get the same answer. So if I do 1 times 2 plus 3, I'm saying that this is the same as 1 times 2 plus 1 times 3. So we know that 2 plus 3 is 5, and 5 times 1 is 5. Let's see if it works. 1 times 2 is 2, plus 1 times 3 is 3, 2 plus 3 is 5. So we've taken this one and we've distributed it first, multiplied it by both of the numbers inside the parentheses. This is a really useful tool when you have something like 75 times 3. What we're saying here is we could take this 3 and multiply it by 70, and then we could take this 3 and multiply it by 5 and add those two products together to make this problem a little easier for ourselves, because I can do 3 times 70 in my head, that's 210, and 3 times 15, or 3 times 5 is 15. If I add 210 and 15, then that's a little bit easier problem than trying to figure out 75 times 3. So this is a useful way to use that distributive property. But this is normally what it looks like for us. Okay, so algebraically, that's going to look like this. A times B plus C is the same as A times B plus A times C. Sorry, I ran out of a little bit of room there. Should have written smaller. All right, so now you've got some examples. I'm going to stop this video, and I want you to try to fill in the blanks over here. Try these on your own. Use your notes. Give these a try. See if you're kind of understanding these or if you have any questions, and then tune into the next video to see how you did.